All right, grade 11s. This is quite a challenging exercise, and so I'm going to try walk you through it as best as possible. We will probably have to go over this sort of thing again when we see each other, but the main part that's quite hard is question A and B. C and E aren't as bad. All right, so the most important thing here is you really need to know your original functions, what they look like, how to draw them, and how to just do a quick sketch of them. So before we start looking at the questions, for the first one, I've drawn in a blue sine graph. I've picked a sine graph because the problem with the sine and cosine graph is they look very similar to each other. So when you're not sure, rather go with the sine graph first and then work your way to the cosine graph, the cos graph. All right, now the thing with the sine graph is it starts at 0, then at 1 it's 90, and then it goes to 180, then down to 270, and then up to 360 degrees. And then it'll do the same but in the opposite direction, going that way. All right, so have the original plotted out for yourself. For the tan graph, this first point, whenever they show you a point on the graph, so you always get the 0 and 0, but then normally this first point is at 1 and 45. So x is 45 and the y is at 1. But now it's at 22, 5 and 2. So something's happened. Right, so we're going to come back to that. All right, so the first part of this is you have to find the equation of this situation. So I'm going with the sine graph first. So sine graph, at this point, we have our first peak at 1, and its amplitude normally is at 1. So this is just y equals sine x. But now have a look at this. I'm going to make it a yellow graph. That one is, it has an amplitude to the midline there of 1, 2 units. So we already definitely know that our amplitude is going to be 2. All right. Then we can see that my graph here, my blue graph, is quite small. Okay, about 360 it's completed its whole piece. But if we look here, this looks enlarged. But the thing is to try and see where is the start of the mountain and then going to the valley. So if we're having a look at this graph, negative 90 going all the way to 270 is 360 degrees. So the period is fine. So we're going to leave the period alone. So what else has changed? Okay, if we had an amplitude of 2, the graph should have peaked at 2. Like this. But instead, it's peaking at 1 and it's going to negative 3. So obviously, if it was supposed to be at 2 and now it's dropping down to 1, and it was supposed to be at negative 2 if we had an amplitude of 2, now it's going down to negative 3, it means we have shifted down by 1. All right, so that's how we're getting this equation here. 2, that's for the amplitude, we stretched it upwards, sine x minus 1. Now some of you say, okay, but what if you saw a cos graph? Well, that's fine. Here is what a cos graph looks like. And so a cos graph's peak is normally, the first one is at 0 and 1. But here, this one's at 90 and 1. So the thing is here, we are working with, we've shifted 90 degrees to the right, which means we have subtracted 90 degrees in the bracket. Remember, if we go to the right, we subtract. What I've done in the next step here is to take out a negative, so it can look 90 minus x. Cos of a negative angle does not get affected, so it just becomes cos of that angle. Cos of 90 minus x still becomes sine x. And then we look at the amplitude and the shift again. So either way, you end up with a sine graph. So that's why I say rather start with a sine graph, check it. If it was supposed to be a cos graph, you'll get a 90 shift and the sine would change to its co-ratio. Or in this case, if you started with a cos graph and it was supposed to be a sine graph, the co-ratio will sort it out. All right. Luckily for tan doesn't have Any co-ratios? So in this case, we are just looking at what has changed here. So we have definitely had an amplitude shift because we're normally sitting at 1, but now we're sitting at 2. So if our y values are stretched upwards, then we are working with an amplitude shift. So definitely amplitude has changed to 2. Then this first point that they always show you on a graph is always shown at 45 degrees. Now it's at 22.5, which is half of that, half of 45. Also, our asymptote, the first asymptote is normally seen at 90. Now it's at 45. So there's definitely a period shift happening because everything's happening earlier. And so the original asymptote is 90. What would have we had to do in order to get it to 45? We would have had to divide it by, not divided by half. We would have halved it, okay? So dividing it by 2 to get 45. So when we're working with the amplitude shift, right, you ask yourself, what would have we had to divide to get to the new asymptotes or the new graph? We would have divided by 2, and we had an amplitude shift of 2. So the period shift of 2, the amplitude shift of 2. Okay. For question 3 and 4, question 3, again, it's got some curve. It's definitely not a tan graph, so I'm going to start with the sine graph. So that is my normal sine graph that I've plotted. But now we're seeing in this case our sine graph, the new one, or the graph doesn't necessarily mean it's going to be sine. That graph there is upside down compared, because here normally there is a mountain. Now there is a valley here. All right, so we have a valley where there should be a mountain. So that probably means that there has been a flip, like a reflection. Also, if you notice, there's no part of the graph, this piece was under, there's no part of the graph that's under anymore, so obviously it's all shifted above. All right, so I'm guessing here that we have definitely a flip, and then if we look, our amplitude from the bottom to the midline is 1, from 0 to 1. And then from 1 to 2. So our amplitude hasn't changed. So our amplitude is 1, but it's going to be -1 because there's been a flip, a reflection. Then if you look, my peak is normally supposed to be at 90 and 1. Now, if the peak was there, it's at 45 and 1. So we have shifted our peak, our point, 45 degrees. Then if we have a look, let's just see. We also have this point over here that normally we should be cutting the y-axis at that point, but then now it's at -45. So we've definitely moved 45 degrees to the left, which means in our bracket we're going to have x plus 45. When we go to the left, we have a positive inside the bracket. In addition to this, if it was just a regular flip, I'm going to do it in a different color. If it was just a regular flip, this piece would be here and that piece would be there. But now everything's kind of moved up a little bit. So it's kind of like here. And it's gone upwards. So we're definitely moving everything upwards as well. So we have an upward shift of +1. So this one's quite a nasty one. All right, so we're putting it as y equals -1 sine x plus 45 and then +1. Let's go back here. Yes, okay. So it's just a bit of a playing around game with that. Having a look at the next one, I'm just seeing this more as a cos graph, but if you're not sure, again, the sine graph will work. So the cos graph it tends to be kind of like a big trough, either like a big mountain or a big trough like that on its own. So in this case, this is very definitely the style of a regular cos graph. Okay, but the regular cos graph will start at 1 and then only cut through at 90 and then go all the way back up and finish its whole valley or trough by 360 degrees. All right, so there's a lot of change happening here. So in this case, you can also see here that the graph is supposed to cut the x-axis here at 90. Okay, so let's just carry this graph on. So it would have been 90 and 270. That point would have been 180. All right, what I've also done here is just I've highlighted the fact that the peak there is supposed to be on the 0, but it's now at -10. So which means we've shifted this whole graph 10 degrees to the left, which means we will definitely have a plus 10 in our bracket somehow. All right, so this piece, everything should be 10 degrees over. So the end of the cos graph here should be 120. So it's definitely a period shift because the whole cos graph is being seen between -10 and 110, which means the new period is 120. And so if my new period from start to end is 120, you've got to ask yourself 360 divided by what would have got me 120. It means we divided by 3. So there's also a period shift of 3. Okay. All right, so let's check for any other situations. So this amplitude is definitely still 1 because we're going from -1 to 1. So there's no amplitude change, no vertical shift because -1 to 1. And so we're sitting with a period shift and we're sitting with a horizontal shift. It's very unlikely that they give you all of the different types. The worst one, like I said, was this one where you had kind of a hidden amplitude because it was a reflection. So even though the amplitude's still 1, there was something that changed in front of the sign. You had a horizontal shift and a vertical shift, but no period shift. So you tend to have 2 main shifts happening in these graphs. So this definitely would be a cos graph of 3 into x plus 10. Now, if you had done it as a sine graph, then you would have noticed a 90-degree shift from where it should be. All right, so you have to then form a 90- relationship to get a cos graph. All right, moving on to question B. Question B, they've given you 2 graphs, a sine and a cos graph. I've just highlighted them accordingly. Please highlight, it really does help you see things. And they're going from -240 to 240. So the hard thing here is they've given you 2 unknown equations. At least you know one's a sine, one's a cos. The sine graph is undergoing a horizontal shift. The cos graph is undergoing a vertical shift, and that's it. So if we were to draw the original sine graph, we would see that our sine graph actually starts at 0 degrees, but now it's, cutting the x-axis at 30, now it's at 0, now it's cutting at -30. So when we're looking at, let's get rid of that, the original to this, we have moved 30 degrees to the left, which means inside our bracket we have a plus 30. So P must be 30 degrees. So P is 30 degrees. Q is a vertical shift, so nothing else has changed with the cos graph except that it's moved. Now, we see that its bottom part of the graph is at -3/2, which is -1.5. It's supposed to be at -1. So the graph has moved a half down. So Q must be negative a half. How do I know it's horizontal versus vertical? This one's vertical because it's not in a bracket. This one is horizontal because it is inside the bracket with the x. The x is being affected. Here, the whole cos graph is going down a half a unit. So then it says, what's the maximum value of g? You need to know the maximum value normally of a cos graph is at 1. So now we have moved it down. The maximum value must be y equals a half. Then for 3, what is the range of y equals negative 2g of x plus 1? All right, so first write down what g of x is. It's cos x minus a half. And then fill in what they've asked you to. We are saying negative 2 times this thing called g of x. So here's g of x. And then we're adding 1. So I'm distributing the 2 in. So it becomes negative 2 cos x. Negative 2 times negative a half is positive 1. Positive 1 plus positive 1 is positive 2. So it means the original cos graph normally has a range of negative 1 to 1. And now it's having an amplitude shift. Don't worry about the negative. The negative just flips it, but it still has the same height above and below the x-axis. So our amplitude shift would have changed that to negative 2 to 2. But then now we are adding 2 in order to get our shift. So for this one, that is the amplitude. We multiply by 2, and then from this point, we need to add 2 to shift upwards. It's over here. So negative 2 plus 2 is 0. 2 plus 2 is 4. So our range is from our minimum to our maximum, 0 to 4. All right. Okay, and then for number 4, determine the equation of h if h is obtained by shifting f. So f is our sine graph. F of x equals sine x plus 30 degrees, and then we are shifting 60 degrees to the right. Oh, that's not right. To the right, which means we are minusing 30. I lied. Minusing 60 because we're going 60 degrees to the right and 2 units down. So the 60 degrees goes in the bracket. And then our minus 2 goes afterwards. So it's going to be sine x minus 30 minus 2, which means the overall effect of going from this piece here on the graph, we're going 60 degrees that way. We're only going to go 30 and another 30 to make the 60, which means we're at 30 degrees. All right. Question 5 is super easy because all you have to do is, they're saying now find point A. Point A sits when x is to negative 240 degrees. So where you see an x, put a negative 240. And now this is from the original function, please, not this new one that's just been found. And negative 240 plus 30 is negative 210. And then you can reduce that if you want to see an in-between step. It's going to be negative sine 210, which is in tan's quadrant, which is negative sine 30 then, which the negative times negative gets us sine 30, which is a special angle of a half. But there was no mention of not using a calculator, so you honestly could have just put this first step into your calculator and gotten the answer of a half. And then your coordinate, don't forget, is negative 240 and a half. Question 6, I know some of you battle with these. We are going to focus a lot more on them in the general functions section, but I will discuss them now and hopefully you at least understand some of them. Okay, so for f of x increasing means going up. So where is the graph literally going on an upslope? So we can see that it is between, let's just get it yellow. So the red graph is going upwards between its two kind of turning points, if we want to call them turning points. So we are normally seeing a turning point at negative 90 and at 90 for a sine graph, because we know that red one's a sine graph. But because the graph has shifted 30 degrees, everything's shifting up. So instead of at negative 90, it's going to be at negative 120. And instead of 90, it's going to be at 60. So between negative 120 and 60 degrees is where the graph is on an upslope. So we write it like this. Either you can say that x is an element from negative 120 to 60, or you can say, like in the memo here, negative 120 to 60 using inequalities. I honestly would exclude, they've included here, I would exclude the equal to here, because on those points they're not increasing or decreasing. That's the point where the graph is changing from being a downslope and becoming an upslope. So that is a turning point. It's not an increasing or decreasing point. But in an exam, we'd likely accept both, but the better version is not including them. All right, then where is g of x equal to 0? The easiest thing just to do is make g of x equal to 0. So in this case, you're going to say cos x minus a half equal to 0. Highlight, there we go. And then take the half across and then shift cos in your calculator. It will be negative 60 or 60. We wouldn't want to add the 360 here. So in this case, we don't want to do a general solution, because if we have a graph that's going from negative 240 to 240, we want specific answers here. If we know that we're going to be putting it in, so for 60 and negative 60, if we were to add 360 to either of those, we're going to go beyond our domain of 240, because negative 60 plus 360 is 300. 60 plus 360 is going to get us 420. So we just want the two main points that we can see here for this graph. So where is g of x equal to 0? Just at negative 60 and, not and, always or, never and, or x is equal to 60. All right, and I've just filled in now all the values that we found, and so we can definitely now work for the rest of the question. So it's saying, where is f of x, so for number 3, less than 0? On a graph, less than 0 means under the x-axis. So where is the x-axis? We are looking at this line here. So where is the graph under? Okay, so it's going to be this little point here to that point, so that little portion, and then it's going to be that portion underneath. So how do we find where that portion is? So if that's 30, it was supposed to be 0. You need to know that this was supposed to cut at negative 180. So that must be 30 degrees. That way it must be negative 210. This normally cuts at 180, but because we've shifted it up, it must be 150. Now, very importantly, we can't include negative 210, negative 30, and 150 as a square bracket or with an inequality with an equal to sign, because we are working with less than 0, not less than or equal to. Add the equal to sign, then you can use them. So you can either use the inequalities like this. We're allowed to include the 240 because it's not on the x-axis, so one's under, not on. Or you can use your brackets. So negative 210 to negative 30, 150 to 240 square bracket. Always x values that they're asking for here. All right, then for question 4, they're asking us, where is f of x, the red graph, less than g of x? Less than means under. So where is the red under the green? Well, we can see here, red is under the green for this piece, and that's about it. So the x values for that, we're always worried about x values, is negative 120 to x is 0. So negative 120 to 0, not including because it was just a less than sign. So if we're looking here, you can also have the brackets to 0, x is an element. And then the last one, you've got to understand the maths language here. So it says f of x times g of x is greater than or equal to 0. So it's saying when we multiply the red by the green, the y values, f of x means the y values of the red, g of x means the y values of the green, we are going to get a positive answer. So how do we get a positive number? By multiplying. Both must be positive or both must be negative. So positive and positive, negative and negative will get us a positive answer or 0. The or 0 just means that we can include the answers if they're on the x-axis. So we're saying we need to see positive in graphs is above, negative is below. So where are they both above or where are they both below the x-axis or both on it? Start at point A. Point A to here, we have the red graph above where the green graph is below. So we can't use that. We need both above or both below. Then you can see from this point, both are below up until where the green graph goes above. Then, for this tiny little portion, the red is below or the green is above. Then the red and the green are above together up until this point, so that will work. And then the green goes underneath while the red's above. So that portion won't work, and then that one will. So there are 3 positions. So it's from negative 210 to negative 60, then from negative 30 to 60, and then from positive 150 to 240. All right, and they can be equal to each other. Right, so it would be square bracket, square brackets, and square brackets. All right. Then moving on to question C. Here, so question C is a little bit easier. There's a sine graph and a tan graph. The sine graph has an amplitude change and a vertical shift. The tan graph has got a period shift. All right, so the first question is, what is the range of f? So the range of f means it's going from the lowest point to the highest point. So they've shown us what the highest point is here. The highest point is at 1, and then here's the midline. So that dotted line is the middle of the green graph. So we've gone 1, 2 units, so then we're going to go 1, 2 units down. So from negative 1 goes down to negative 3. So my range is going to be y is an element from negative 3 to positive 1, including both. So it's your minimum to your maximum. All right. You always start with minimum, then go to max. Then for number 2, determine the values of A, B, and C. So A is looking at your amplitude of your sine graph, and then B is looking at the vertical shift. We'll come back to the tan graph. So if we look at from minimum to maximum, that is 4 units. Halfway would be 2 units. So we can see from the minimum to the halfway, or from the maximum to the halfway, is 2 units, so which means the amplitude is 2. So the value of A, which is the amplitude, is 2. You've got it up here. Then B, if your amplitude was 2, you would supposed to see a graph at 2 and negative 2. But now we're seeing it at 1 and negative 3, which means the whole graph is shifted down 1 unit. So B is the vertical shift of negative 1. All right, now we're going on to the tan graph. Because looking at the sine graph, there's been no horizontal shift. It means this point P is at 90 degrees. Now, for the tan graph, that's supposed to be where your asymptote is. But in this case, there's clearly no asymptote there because this, if it was here, the graph is running through it. So our asymptote is moved, all right, and it's gone somewhere. It's sitting somewhere here. Let's just change that to blue. It's sitting somewhere here. All right, then also this first point that they always show us is supposed to be 45 and 1. Now we've got 90 and 1. So that's the key point. The fact that 45 is not with its usual 1, 90 is now with 1. So which means we have gone from 45 to 90 by dividing. So how do I divide something by a number, 45 by a number, and get a bigger number? It means we must have divided by a fraction, and then you tip in times. So that's how the C value is, a half. Right, so that means our asymptote is actually sitting at 180, because it's supposed to be at 90, and now it's going to be divided by a half, which means we're doubling it. So then for number 3, it says, what is the range of y equals negative f of x plus 1? So fill in f of x is 2 sine x minus 1. So y is equal to negative f of x plus 1. And so you distribute the negative in, add 1, and you get to this graph here. So which means we've had an amplitude shift in the sense of we have reflected, and then we have added 1 as well. So our range is supposed to be, for a sine graph, so if we just had a plain sine graph, it would be negative 1 to 1. So now this plain sine graph is being reflected by negative 2, so we're going to multiply everything by negative 2. So the range should be negative 2 to 2. Always put in the right order. And then I'm shifting up by 2. So everything has to have 2 added to it. So negative 2 shifted up is 0. 2 plus 2 is 4. Sorry, please, square brackets. So that's how they're getting this negative 0 to 4 from that graph. So it is very important to know your original graphs. For question 4, it says write down the equations of the asymptotes of G. So normally it's at 90, but now we are taking the 90 divided by the period for the asymptote. So 90 divided by a half gets you 180. And considering the scale of this graph in the domain, we can see that there will be definitely a negative 180 and a positive 180 asymptote. Please, it did ask you for the equation, so it's x equals 180, x equals negative 180. So you need to know the original asymptotes are 90 and negative 90 within the zone here. Right, for number 5, write down the equation of h if h is obtained by reflecting g in the x-axis and shifting it 2 units down. So when we reflect a graph, we change the front of it to a negative, so right in front. So we've reflected it in, when we reflect it in the x-axis, and when we shift it down 2 units, we subtract 2 from it. Question 6 is something that I don't think you have covered before. So if you didn't know how to do it, then please don't think that you are lost. Again, everything at the moment is as we go along, as we find it, we'll do it. So it says, for what values of k will the equation f of x equals k have no real solutions? What this is translating to is you've got to imagine that there is a line, a perfectly straight line going through, and k is that graph. So we have y equals k, and we have y equals your f of x graph, your normal f of x. So we're saying, where are these two going to be equal to each other? So where is my green graph going to equal my red graph? Well, in any position between the maximum and the minimum. Because once it goes out of the maximum and the minimum, then it's not going to cut the green graph. Don't worry about the blue graph, the green graph. So anything that is even just the slightest bit beyond the top and the bottom of the green graph is not going to work. So that's why it's saying we'll have no real solution. That means it's not going to cut at all. So it's going to be anywhere above the top of the graph, anywhere below the bottom of the graph. So the top of the graph is 1 and the bottom is -3. So that's why it's saying anywhere above or greater than the top, or anywhere less than the bottom. Not equal to, because then they will be equal, it will have a solution. We want no solutions. If it's touching on that spot, then it'll have one solution. If it's touching on that spot over there, one solution up there. If it's cutting in multiple places, that's 1, 2, 3, 4 solutions. So depending on the question will depend on where you'll have a look at. Then the last one for question C, for which value or values of x is f of x greater than or equal to g of x? So where is it above or equal to? Where is the green graph above or equal to the blue graph? All right, so where is my green graph above? Over here. And this tiny bit over here. Maybe we said that's 90. This piece does not work. The green is below. Here, up this tiny little piece here, it's below. But then suddenly it comes above here. So it's at that asymptote that there's a change. That asymptote's at 180, where the green graph is above. And then from this point, that does not work. So it's got to be between 180 to 225. Then it's going to be, let's just see, this 45 to 90. And anything less than negative 135. All right, so they say negative, and because here's our negative 180. So that's where the graph would stop. So negative 180 is our asymptote to 135. They are allowed to equal each other, according to the question, greater than or equal to. We just can't include the 180 because it's an asymptote. So square brackets there. 45 to 90, we can include both square brackets. 180 is an asymptote, so we can't include it, but 225 can be a square bracket. E is nice because I've given you the equations. So the yellow graph and the green graph have been given. The yellow graph has had an amplitude and a vertical shift. The green graph has had also amplitude and vertical shift. And they're going from negative 360 to 360. So we know at least that this piece, negative 360 to 360. All right, then they say to us, what is the amplitude of f? So f, we look here, the amplitude is the number in front of the equation, so the amplitude is 2. That's where they found that 2. Then what is the period of G? Well, the period for both of them is 360 because there's nothing in front of the angle, so 360. Question 3, what is the range of G? So you've got to know your original, the range of the original cos graph should have been negative 1 to 1. But now we've had an amplitude shift, so multiply by negative 2. And then take away 1. So that's going to be 1, negative 3, and put it in the correct order from minimum to maximum, negative to positive. Then question 4, for what values will our yellow graph be above or on our green graph? So let's just get rid of all this other stuff. Okay, so where is our yellow graph going to be above our green graph? Well, it's definitely this piece, that works, so negative 360 to whatever that point is. Then the green is above up until that point, so that won't work. Then we want this piece to that piece, that will work, but then the green's above, and then this piece will work. So we've just got to figure out what those points are. Okay, so in order to figure out what this first point is, let's just have a look here. The yellow graph on the y-axis is normally supposed to cut, a sine graph cuts at 0. So now it's shifted up 1. So this piece, if we shift it down, would be cutting, and that happens at negative 180 for the sine graph. Right, so it's negative 180 is that line here, so it's going to be negative 360 to negative 180. All right, so we'll deal with that in a second. Then here to here, we've got to figure out, and that piece to here. So then this piece of a sine graph, so I know it's a bit hard to see with everything written on it. Let's just do it in a different color. So that's like the valley of the sine graph is supposed to happen at negative 90. We've had no left-right shift, so it's still happening at negative 90. So from negative 180 to negative 90, that doesn't work, but negative 90 does. And then going all the way up this whole piece here, that works again. This is supposed to be down 1 unit for the original. That happens at 180, so negative 90 to 180. Then this piece is supposed to sit at 270, so you need to know your main points of a sine graph. So if we look here, it's 0, 90, cuts at 180, the next mountain is at 270, and it ends at 360. So here 270 is the next value point. So negative 180 to 270 doesn't work, but 270 to 360 does work. All right, so they've given you all those options there. For the last one, question 5, it says use the sketch to determine the values of x for which sine x plus cos x equals negative 1. The first thing before we start working on using the sketch, we need to break apart what they've actually given to us. They've said, where is sine x plus cos x equal negative 1? When they give you questions like this, you've got to try and manipulate to get back to the original functions. That's what they're trying to see here. So in this case, let's take the cos over, we get this piece, negative cos x minus 1. So how would I get it to look like the original? I could multiply everything by 2. So everything's been multiplied by 2. But then we are still missing that plus 1 on the sine graph. So we're going to add a plus 1 to both sides. You're more than welcome to do this as long as you balance it out left and right. So then this is now your g of x and f of x, and this is now your g of x. So it's actually asking you, where's your f of x graph equal to your g of x graph? And it's at these points here that we've already discussed. I did erase them, but that is at negative 90. That's at positive 90. No, not positive 90, sorry. That one was 180. That was at positive 270, and that was at negative 180. Right, so negative 180, negative 90, 80, and 270. Okay, again, in an exam or a test, you get one trig function. So it will be sort of like question E or like question C. You won't get right from question A to question E. There'll be some easier questions, some harder questions. And so the more you know your originals, the better that it is. You start to see it. It's much easier to see. When in doubt as well, you could also sit and put each of these graphs into your calculator and actually plot the points out and see what points you'd have plotted, and then work from there. That's also fine. But getting to know your original graphs is also quite important. Right, that's it for trig functions. That's it for my videos, grade 11s. Mr. Gomes will be putting up some stuff for functions, but not in too much of a rush. Get through all the trig stuff first, and then when we get back to school, we will be doing regular functions and geometry, and then come back to the trig work once everyone's caught up. All right, so good luck with everything, and hopefully see you all soon.